Hi everyone, welcome back to Mind Maths with Amina. In today's lesson, I'm going to show you the intuition behind the Bellman equation without using any functional forms. We'll take a finite horizon decision problem and solve it step by step using a technique called backward induction, and you will see how the dynamic programming actually works, and you'll be able to understand what the Bellman equation that I stated in the previous video actually represents. Okay, so this is a question given in a study guide given by University of London. The course name is called Optimization Theory. The question is to consider the problem facing a city council in developing a new public tram route. All the tram routes must terminate at the city depot, and there can only be 6 stops along any route between start and finish. So this is the end point, and these are the starting points. So we have our journey can start from these 4 points, routes, stations, whatever, and they're going to end up at one place. Okay, the final decision process has reduced the number of precise starting locations to 4 places. An overall route must be chosen from the possible path listed below. So the person has to choose a path from either of these 4 starting points till the end point, such that either the question will tell us if we're looking from the point of view of the producer or the consumer. So the consumer might want to reduce his traveling cost, while the producer would want to maximize the revenue from such traveling. So let's see what the question says. In this figure, the possible starting points are the nodes 2, 1, 4, 1, 6, 1, 8, 1, while the depot lies at the node 5, 8. 5, 8. Okay. At all but the final node, there are no more than 2 possible paths for a tram route to follow. Attached to each path is the revenue expected from each leg of the route. So this means we're going, the numbers here represents the revenue that the producer is going to earn when the consumer travels along these paths. Okay, let me highlight that this is the revenue in thousands of pounds per week. Since the cost of laying the tram rails is fixed regardless of the particular route, the problem is to maximize the weekly revenue from the tram route given the payoffs above. Okay, so our objective is to maximize the revenue. You could get a similar question in which you'll have to minimize the total costs. Okay, and the procedure that you will have to follow is going to be exactly the same. Okay, as a first step to such a question, as you can see, unlike the previous questions where we had to maximize an objective function given a constraint, the objective function over here is not given. And even the constraint, the functional form of the constraint is not given. So we have to identify the elements in this scenario. So the step 1 is always going to be the identification. We need to identify the elements of the finite horizon dynamic problem. Okay, so first of all, we have to state all the states that are available given by the set S. Okay, let's see. We have a 2, 1, 4, 1, 6, 1, 8, 1. Okay, so we have a 2, 1, 4, 1, 6, 1, 8, 1. Sorry, I have had a bad throat since 2 months. Okay, the next is, okay, 1 2 3 2 5 2 7 2. Okay, so 1 2 3 2 5 2 7 2. And you can see, like, you have to state all of the stops that are available. So I don't want to waste time. I'm just going to write dot dot dot, and we end up on the last point, which was a 5 and 8. So everything ends. That's the last state that is available. So these are our state variables. Okay, what are the set of actions that are available? So the person can either go right or left. Okay. So one option is to go rightwards, and we can represent that by a +1 sign, and the other option is to go leftwards. That can be represented by a -1 sign. Okay, the total time periods is in this scenario, it is 7. And I write 7 because this is the last stage, or as in the last moment at which we must make a decision. Take a decision. Remember that island example that I gave when we did have the functional form? I was explaining that imagine that you're stuck in a island for, suppose you're stuck there for 10 days. So the last day that you have to make that decision is the 10th day, and afterwards you don't need to make any decision. So in this scenario, the first decision they're going to make is over here, the second here, third, fourth, fifth, sixth, seventh, and this is the last decision because there's no decision afterwards. So that is why we're going to take the time horizon as 7 time periods. Okay, what is the reward function? It is basically just given in the diagram on each path. So it's given in the diagram, attached actually to each path. So the reward is not a function that is given, it's along each path the reward is mentioned. For instance, 4, 7, 5, so on. Okay, what is the function that takes us from one state variable to another? It is simply shown by the movement, the actually upward movement along each path. That is, it's a movement from one node to another. So it takes you from one state to another state. We can also write it like the state in the next period is a function of the state in the current period and the action that you take in the current period. Okay, so for instance, it could be you're currently sitting in the node 2, 1, and you go towards the right. So for instance, you were at 2, 1, and you take a right and you end up at 3, 2. So the function will tell the new state as being the node 3, 2. So the function basically takes us from one state to another. Remember in the previous lesson, I said the dynamic equation of capital accumulation is given as this, and this is the state variable. So this again tells us the action that we are about to take and the previous period state, and it will give us the new state of the economy, which in this case was the level of capital. Okay, let me delete this. Okay. Then we have to state the set of feasible actions. Remember, in a question like this, if you don't state all of these, what do I say, these elements, then you won't get any marks. It is imperative that you mention these elements of the FHDP. Okay. Feasible actions at each stage can be seen from the diagram, and where the feasible action is simply a subset of the set of actions, where the set of action was going right and going left. Okay, so step 2. This is the main step. Step 2 is quite fascinating, and I've actually always enjoyed this part. It's called backward induction. So I think you guys you'll also enjoy this part if you're into mathematics. So the person actually is going to start from the last time period. He has to make a decision. So that's the 7th time period. And what are the states available to this individual at this time period? Let's see. He is going to be over here and over here. So these are the states that he could possibly be in at time period 7. So it is a 4, 7 and a 6, 7. Okay. So let's mention the states that are available to him. 4, 7 and a 6, 7. And the set of actions available at this time are actually, at each node it is going either a right or a left. Okay, so what is the reward if he is at 4, 7, the node 4, 7, and he goes right? Let's go up and see. So if he is at 4 and 7 over here and he takes a right, he's going to get a reward of 7. And if he is at 6, 7 and he takes a left, he's going to get a reward of 4. So a 7 here, and if he is at 6, 7 and he takes a left, he's going to get a 4. Okay, remember that the max, since at 4, 7 there was only one option to go right, there wasn't any option to go left. Same over here. So the maximum utility that or revenue that can be obtained at 4, 7 node is a 7. Similarly, the maximum of supremum your revenue that can be obtained from 6, 7 is a 4. So remember another terminology, the GTS function basically just tells us the optimal action to take at time period t. So what is the optimal action? Let's see. So the optimal action at time period 7 from the node 4, 7 is actually a rightward movements, and we get a maximum utility or revenue from this function, from this action as being 7. Again, at time period 7, the optimal move to make is going left, and this will give us the reward of a 4. And basically I'm going to now make a box here to tell myself that these are the optimal or the maximum revenue that can be generated at time period 7. Okay, now what we're going to do is I'm going to go back one more time period. Okay, when t is equals to a 6, what are the states that are available to our individual. Okay, it is 3 6 5 6 7 6. Okay, so the states available are a 3 6, a 5 6, and a 7 6. And the set of all possible actions is again a right movement or a left movement. So we are basically now interested in the reward from the state 3 6 when he takes a right from, because from 3 6 there's only from 3 6 there's only one option going right, and from 7 6 there's only one option of going towards the left. However, at 5 6 node, when you're in the state 5 6, you have two options. You can either go right or left. So let's see, the reward from position 3 6 on going right is given by 2. So the revenue at taking a right from the node 3 6 is going to be, okay, so what is, remember, this is going to this is the reward that I'm getting at time 6, and also the reward that I'm going to get if when I end up at time period 7. Okay, and I'm going to actually, when I take a right from 3 6, where am I going to end up? So from 3 and 6, this is a 3 6, so when I take a right, I'm going to end up at 4 7, and I already know what lies ahead if I come here, right? What lies ahead if I come at this state is the reward of 7, so I'm going to add that. So the total reward is therefore a 2 plus a 7, and therefore a 9. So what we can conclude is that the maximum utility at time period 6 when you are at the node 3 6 is going to be a 9. Okay, now let's move on to the reward at time period 6 when you are at the node 5 6. As you can see, there are two options here, right? You can either go left and get a 6, and then go right and get an 8. If you actually decide on taking a left, you're going to get a 6 plus a 7. And if you take a right, you're going to get an 8 plus a 4. So he's now going to have two options. Should he pick 7 plus 6, which is a 13 revenue, or should he pick 8 plus a 4, 8, 9, 10, 11, which is 12? So as we can see from this, the highest revenue is if he takes a left and he ends up at 4 7, and after that he's going to take a right and he's going to get a 7. So let's write this out mathematically. At point position 5 6, if he takes a left, he's going to get a reward of 6. So the total value or reward of taking a left from the node 5 6 is first the reward at the immediate reward at time period 6, and then the reward that he's going to get from the periods that come after the 6, right? And since he's going to end up at 4 7, we are interested in the reward stream that takes us forward from 4 7. So we have a 6 plus a 7, which is a 13. Okay. However, if he started from 5 6 and chose to go right, he would have had the reward of 8, which over here it seems like the better option, but he has to look at the overall scheme of things. So if he takes a right from 5 6, the immediate reward in that time period is an 8, but we need to see the reward that he's going to get from the future moves the after time period 6. So since he's going to end up at 6 7 if he takes a right, we are interested in the value of that node. So we have a 8 plus a 4 and total 12. So what is the maximum utility, as in not utility, revenue from the node 5 6 is just going to be the supremum between 13 and 12, and it's a 13. So what we can highlight now is that the value, the maximum revenue at 5 6 is a 13. I'll highlight this and this. Okay, what about reward from the last node at time period 6, which was a 7 6, and there the only option is going left. Let's see what the reward was. Okay, from 7 6 the only option is to take a left, and we know from here the only option is a left again. So the overall reward of taking a left from this node is going to be a 3 plus a 4. So let's write that down. The reward of the immediate reward is a 3, and the reward from taking a left from the node 7 6 is the immediate reward, and the maximum reward from all the future time periods. Okay, so we have a 3 plus a 4, which is the settlement. Since this was the only option, therefore the maximum revenue from the node 7 6 is a 7, and I can basically now highlight this. Okay, so writing down the conclusions again. The optimal action at node 3 6 is a plus 1, which is going right, and this gives me the reward, the maximum reward, the maximum revenue, the maximum utility as being 9. Okay, at the node 5 6 the optimal action is taking a left, and I end up with the maximum revenue from the node 5 6 being a 13. Okay, and the last node is a 7 6, and if I take a left from this state, I will end up with a total reward of a 7. So this is my maximum reward if I go along these paths. I'll do one more time period, and then you'll get the hang of this, and then I'll pause the video. Actually, I'll cut the video and I'll solve the remaining question, and you can also solve the remaining question, and then you can continue the video. So I would suggest that you solve the whole question by yourself. Just pause the video when I stop after this time period, and see if you got it right. Okay. At time period 5, the available states are a 4 5 and a 6 5. Okay, a 4 5, a 4 5, and a 6 5. And the available actions at this time period is a right or a left. Okay, so now we are interested in the reward at time period 5 of when you're at the node 4 5 and you take, what is the option available at 4 5? Okay, at 4 5 you can take either a left or a right, and even at 6 5 you can take either a left or a right. So we have both options here. So you can take a right or you can take a left. So, And even when it comes to the other node, 6 5, again you have the option of either going right, or you have the options of going left. So let's see the rewards. Right, left, okay. When you go right, you get a 5. So 5 7 5 1. Okay. Let me write this down. 5 7 5 1. Great. Okay. So the value of the utility of taking a right from the state 4 5 is the immediate reward that you get from at time period 5 plus all the future rewards you will get at time period 6 when you end up. Where will you end up? So if it is a 4 5, 4 5 and you're going right, then you're going to end up at a 5 and 6. Okay, so what all the future rewards for ending on a 5 and a 6? We've already calculated that. All the future rewards are a 13. So we're going to do a 5 plus a 13 and we're going to get an 18. Okay, great. Let's see the reward stream over here. Okay, so the reward that I get from taking a left from 4 5 is the immediate reward of that action at time period 5 plus all the future rewards I'll get at the next time period. And if I take a left, I'm going to get a be at 3 and 6, right? So the immediate reward is a 7 and all the future rewards is a 9. So I add a 9 and therefore this is a 16. So what is the highest reward list? So I'm going to write the value, the maximum value at the position 4 5 is an 18 and the optimal action would therefore be a plus, right? So this is the revenue and the optimal action at position 4 5 is going to the right. Okay, let's continue. The reward of taking a right at the node 6 5 is the immediate reward plus all the rewards at the next time period. When you end up, since it's a plus 1, you're going to get a 7 and a 6. The reward for 7 6 all the future time periods was a 7. So we have a 5 plus a 7, which is a 12. Sorry, I should keep my phone on silent. Okay. And what about this? Why did I write a 1? I don't remember seeing a 1 actually. Was it a 1? I hate scrolling up. Let me open the study guide. This was the study guide. Yeah, it is I think we were here. 1 and 5. Yeah, it is 1. Okay, so the maximum revenue of taking a left from 6 5 is the immediate reward plus all the future rewards from taking a left. A left would mean you're going to end up at 5 6 node. So this is a 1 plus all the future revenues are actually at, when you end up at 5 6, you're going to get a 13. So there's a 13. So you get a 14. So let's write the conclusions that, I've already written the conclusion for this one. Let me just make it such a way that it kind of stands out. And the optimal action at time period 5 when you are at the node 6 5 is going left, and the maximum utility from this movement is 14 is greater than a 12, right? So it should be a 14. Okay, so now I want you to pause the video and keep going backwards and solving this for T4, T3, T2 and T1, okay? And let's see if our answers match. But I hope you're able to see that what we're doing is that we're seeing the value of the state variable such that we are basically maximizing the utility at that time period when you take that action, plus you all the future, the value of all the future actions which come from the next time state variable. This is the equation, this was the Bellman equation that we were using in the previous lessons that I said. So I hope like you are able now to understand the history behind, or the theory behind why this is known as the Bellman equation. Because let me repeat myself, you are maximizing the utility, or basically the revenue, from the same time period, and all the stream of rewards that you will get from taking this action, which makes you end up on the next state variable. So this is all the future stream of rewards, and this is the current stream of current reward. And your objective is to maximize not just the current reward, but also the future rewards that you will get from taking this action. In our example, we were there wasn't any utility, we were maximizing the rewards. Okay, so pause the video. I'm also going to cut the lesson here and solve the question, and hopefully our answers will match. Okay, so I hope all of you solved this yourself and you got the same answers. I did the same technique that I did for time period 5, 6 and 7, and I just kept working backwards till I reached time period 1, and I saw that the highest revenue possible for the government to earn is a 42. So now what I need to do is just write the T history, which is basically all the actions that he should take in order to get the highest revenue. So let's write it down. So the T history is as follows, that he starts his journey at 6-1, node 6-1, and he takes a optimal action which is going left. So he takes this optimal action of going left, okay, and he's going to end up at 5-2. Okay, so let's write that he's going to end up at the state 5-2. 5-2. Let's go up. At 5-2, his optimal action is to take a right. Okay, so the optimal action is to take a right. Let me write that down. In the T history, we need to take a right, and when he takes a right, he's going to end up at 6-3. Okay, let's see what he should do from 6-3. From 6-3, he should take a left. Okay, so he should now take a left, and he is going to end up at a 5-5-4. 4. Okay, let's write that down in our history because this is something which the question requires. So he has to take a left and he's going to end up at a 5, 4. Okay, from 5, 4, he has to again take a left. Okay, so he's going to take a left again. So let me write that down. From 5, 4. When he takes a left, he's going to end up at a 4, 5. So let's see his optimal action at 4, 5. At 4, 5, he's going to take a let me see, at 4, 5, this was a 6 and a 3. 6 and a 3, he takes a left, he ends up at 5, 4. Yeah, then another left, he ends up at 4, 5. Okay, 1 step 4, 5. Here we go. Let me highlight this. And from here he needs to take a right. Okay, so let's write down a +1. He needs to take a right, and therefore he's going to end up at a 5, 6. What is his option at 5, 6? At 5, 6, he should take a left. Okay, so when he takes a left from 5, 6, over here he's going to take a left from 5, 6. Oh, I forgot one thing. From 4, 5, from 4, 5 he has to take a right and now a left. Okay, so when he takes a left, he's going to end up at a 4 and 7, a 4 and a 7. And from there, I don't even need to look at my working. I know there's only one option going towards the right. So this is the optimal, the path that should be taken in which the government's revenue from such a person's traveling will be maximized. Okay, so let's write that. Plus a 1, and he's going to get to a 5, 8. Yeah, and that was the last state. So the highest revenue of 42 is obtained via the following path, which is he has to take a left, right, left, left, right, left, right. Okay, so a left, a right, a left, a left, a right, a left, and a right. So that basically captures the whole idea, what the basic intuition which I wanted everyone to understand from this example is why the Bellman equation that we made in the previous lesson looked like this, why we wanted to maximize the utility when you are at this state, and it was basically you wanted to maximize the objective function, which was the utility function, when you were at this state, and when you were at actually utility was in that the consumption was the level of consumption was our control variable. Okay, and so the objective was to maximize utility of the same time period plus the stream of utilities that you will get in the future from the state that occurs after you make the consumption decision. So if I replicate this into the question above, we had a state variable s, we had reward that was given because of an action left right we were taking, and we wanted to maximize the stream of all future rewards from taking action 80. And basically, this concludes the lecture. I found this method very helpful in explaining the intuition behind the Bellman equation. Anyhow, this is this is the full intuition. The Bellman equation isn't magic. It's simply comparing actions at each stage and picking the best continuation value in the next future time periods. And I hope this video was helpful as much it was for me. And inshallah, I'll see you in the next one. Take care.